screening of what's going to be a delightful, not scary, very comfortable, pretty chill film. And none of you are going to have nightmares for the rest of the year. I am going to tell this story. So for my birthday a while ago in LA, they were screening The Fly, and I brought my partner Emily to The Fly. She had never seen it before, and she never forgave me after that. And then I thought, what would be better than make her watch it again? Anyway, so I'm Eric Leonardis. I am a PhD candidate at UCSD in cognitive science. Cognitive science is a mixture of sort of different sciences. It is psychology, neuroscience, philosophy, computer science, AI, anthropology, linguistics. And what we try to do is we try to look at the mind and mental processes from all of these different angles to try to sort of figure out how the mind really works in real life contexts. Okay. Strobe fly. Okay. All right, so the real reason that I actually want to come is so that I can see Jeff Goldblum naked again. But there's a lot more to it, and I have a lot more to share in that regard. So that's not all that you're going to do. So the film is centered around this question of the possibility of teleportation. Okay, so this led me to examine whether teleportation was indeed possible and under what conditions can it be done, and that's what we're going to be discussing today. All right, so when I use the word cloning, I don't want people to get confused. In biology, when you clone something, you have like a biological copy of the same DNA, and then that's not what I'm talking about. Now, cloning in physics is a little bit different. The idea of cloning in physics is that you actually are able to make a perfect copy of that particular individual, all of their particles, all their atoms, all their cells, etc. Okay, and that's what they mean by cloning. Okay, and what I'm going to introduce today is the No Cloning Theorem, okay, from quantum mechanics, which is I'm not a quantum physicist. And if there are any physicists, which I know there are actually physicists in the room, which is great. But I just kind of read up on it, and I'm going to share some stuff with you. All right? So in order to teleport someone somewhere else, what you have to do is you have to first scan all of the particles and all of the positions of all of those particles for that particular individual. Okay? So you need some process by which you actually find where the position of each of those particles are, okay? And then you can represent that as some kind of information pattern, okay? So you have to do some kind of body scan that looks at the particular and the molecular and then figures out what's there, okay? And then we gotta send it somewhere else, all right? So the only limitation, as far as I know, about sending signals in the universe is the speed of light, okay? So as far as I know, what we can do is we can scan all of these particles, send that information somewhere else, and then what we need is we need a procedure for materialization, okay? You need to take raw materials. Ooh, does this have a little, oh, there's a laser pointer too. This is the best. Okay, so you need raw materials right over there. Okay, and you need to have some kind of procedure for turning those raw materials, given this information scan, and then produce an actual body on the other side with some kind of teleport. All right, so that seems okay. All right, so here's the math. I bet you didn't think we were going to do math today, but I got you. All right, but it's not going to be hard math, so don't worry. Okay, so what we're going to do is we're going to do a proof by contradiction today. Okay? So the way that you actually do a proof by contradiction is basically you assume that the thing is false, okay, and then you'll find a contradiction, or the other way around. You could assume it's true, right, and then find some kind of contradiction in the mathematics. Okay? So, 3 properties of quantum particles. Now, I know this is getting really notational, and I don't even quite understand it myself, but here's my little breakdown. So, superpositions, number one. Okay. So, particles can be in multiple places at the same time in quantum mechanics. Okay? I don't know. You have multiple positions at the same time, so they actually add together. Okay? So, when you have superpositions, you add all of those positions together. All right? Now, when you have composites, which are basically multiple particles that are interacting with each other, that is, if you have atoms, if you have molecules, if you have cells, then those things are actually multiplied together. Okay, so we have addition and we have multiplication. Yeah, all right, so that's all stuff that everyone's familiar with. And then this property right here, which I'm not going to be too concerned about, is about linear separability, but that's a fancy way of saying that, hey, when you have these things added together in this transformation or function, okay, what you can actually do is separate them. You do the transformation on each of them separately. Okay? So that's all we have to know about quantum mechanics to do the no cloning theorem. Okay? Now, it turns out, with this proof by contradiction, that if you assume that cloning is possible, and you plug it into these quantum equations, what you get is something really funky. So if cloning is true, then a plus b, with parentheses on the outside, squared, equals a squared plus b squared. Now, that, we all know, is not the right answer. Now, in high school, we did things, I actually failed physics and math in high school, interestingly enough. But I remember having been taught the FOIL method. And the FOIL method is when you basically take these two little guys, and then you got an a plus b over here, and you got an a plus b over there. And then you do the first, you multiply the first, and then you do the inside, and then the outside, and the last. You guys remember that? Okay, well, the answer comes out to be a squared plus 2ab plus b squared, as we all know, and that's called polynomial expansion. Okay? So if cloning is true, then polynomial expansion is false. Okay? So that doesn't seem right. Okay? So either cloning, making a perfect copy of another human being is possible, or algebra is false. Okay? So that's the no cloning theorem. Now, what we actually, oh, okay. So, sorry. What we actually get from that is that since you can't have a copy of you, it can't be that you're scanned and then another copy of you shows up somewhere else and then you're sort of like deleted, but you're already made. What has to happen is you have to be destroyed and then recreated. Okay? Because you cannot have copies, what you have to do is basically scan the thing, okay, and then destroy the thing, and then make it somewhere else. Now, another weird thing about quantum measurement is that when you actually measure the system, you change the system. So one of the big problems in teleportation is that it might not be the same you that's coming out the other side, okay, and that's worrying. Right? If the scan is going to like change some stuff and then there's like a different you coming out the other side and then you're like destroyed, we might have something to worry about. Okay? So those are the limitations of teleportation, but now the caveat to that is, and I know when I talk to a few different physicists about this, they're like, no, like it's fine. Like what if it's like 97%? That's good enough. You know? Like most of the particles are there, it's pretty much you, just get over it. And I'm just like, I would like it to be the same me if possible. But anyways, let's move on. Okay, so teleportation, plausible, and only limited by the speed of light, but you have to be destroyed and recreated. Okay, now, the flesh. Let us explore the flesh. Let us think about the flesh together. And let us think about what our new flesh could possibly be. All right, so anyways, in cognitive science in the 1960s and 70s, a lot of really famous and popular theories posited that the mind is an information pattern. Okay, the mind is not necessarily based on what it's made out of. The mind is a series of processes, a series of like computations. Okay, and these computations can be performed on anything. It could be performed in a body, it could be performed on silicon, it could be, on tape reels, something like this. As long as the mental calculation is taking place, then we can call it a mind. And this is what I'm going to take issue with, and this is why I chose the fly, because it might actually matter what you're made of. Okay. All right. So, in the film, and I don't want to give away too many spoilers, but what happens is they try to take an organic thing, a steak, okay, and then they try to teleport it from one side to the other. And then Brundle asks Ronnie to taste this steak, and she says it's just no good. There's something wrong. It doesn't taste like a real steak. Okay. Then they get it on, and somehow he can make a really good steak. Basically, what he did was during this sexual encounter. They talked about how the flesh makes them crazy. Okay? There's something about the flesh that inherently makes you react with some kind of aggression, right? It's like when a grandmother pinches a baby's cheek, or when you see something cute, you just something like that. So in the film, it's kind of like left up to question, but it seems like Seth Brundle has learned something about cute aggression. This phenomena that when you see something that makes you so happy and joyful, you just want to kill it. So he programmed this into the computer. He taught the computer how to be crazed by the flesh. And then he actually made a good steak. Now I'm not going to give away too much more. Okay? Now, so in the fly, now we know that there is some kind of mutant that is created that is half human, half fly. And you'll find that if you look at the genome, that is the genetic code, the DNA of the fly and the DNA of the human, we actually share 61% similarity. And that's actually a lot. It seems like so that's interesting. And if a human-fly hybrid was actually made, then that 61% would actually jump up, because we already share that much, right? So we have about 39% difference. Okay, so if you kind of cut it in half, that means Brundlefly is about 80% human. Okay, and that's actually that's a pretty good amount of genetic similarity. Okay, but comparing genomes is a crapshoot. So no one should ever believe anything that I say. Anyway, everyone, we're scientists here, so you should always be skeptical. And basically, what's really interesting about comparing genomes and percentages is that, for instance, if one piece of the sequence is missing, do you just treat it as an empty space, or do you just delete it and then put the thing next to it in front of it? There's a lot of sort of leeway in how these genomes are actually compared, and there's a lot of arguments about that. Okay, now there's two flies schmanging it right over there, and now one interesting sort of trivia or sort of fact about flies is that their sperm are exceptionally long. Okay, so human sperm are about 0.05 millimeters long. Okay, fly sperm are 2 centimeters long.
No way.
And they're tiny. Okay, so if you actually were a human, you were an adult human, and you're going to turn into an adult fly, your sperm's gonna I think that's a very interesting biological. Okay, so in the previous film, in the 1950s, you had a human that goes into the teleporter and a fly, and what comes out is actually a fly with a human head and a human arm, and then you have a human with a fly head and a fly arm. Okay, that's the original film, and it looks kind of like that, right? And in the Cronenberg version, we have this body that is slowly degrading by some kind of cancerous, degenerative thing that slowly morphs him from an adult human to an adult fly. And I'm actually going to take issue with some of these ideas, and I'm probably going to say that the original fly seems a little bit closer to the actual truth. That is, if you actually did splice the genome, and you did actually, put all that fly genetics in there and make them come out the other side, then you should probably be fly-like already the second you come out. Now, in this other version, there might be, and I talked to a scientist at the Salk Institute last week about this, and they were saying that there could be some kind of epigenetic effect. Okay, now the epigenome is actually something that exists sort of on top of the genome. It determines when the genes are turned on and off. And what it could be is that this teleporter was a little bit funky, and Brundle maybe wasn't actually totally on, and there's some kind of epigenetic effect that he hadn't been aware of that basically slowly turned these genes on, which results in transformation. But that's a stretch. Okay. Now, here's another thing. Now, this is another reason why the original fly would have been a pretty good interpretation. The compound eye that a fly has, they're quite different from our eyes. And if humans did have a compound eye, that's how big it would be proportional to our body. And that actually, like, if we go back to the other one, hey, that looks a lot more like that guy than that guy. Those didn't look like compound eyes. Those certainly are, okay? Now this is the real good stuff. Now, this is a fly embryo as it's developing, and what you see is something called patterning and body segmentation. So this is actually forming a larva, and slowly what you'll see is you'll start to see 11 segments forming right here, okay? And this body plan happens through embryological development, okay? Now this is one of the biggest evidence against the fly, okay? I actually was talking to my friend who is a developmental biologist, and they were just like, hey dude, like this is not gonna fly, like it's not gonna fly. This is, like if the teleporter takes an adult human, right, and they're supposed to turn into an adult fly without ever having gone through development, it doesn't seem like you can grow 6 legs without having gone through this type of body segmentation. Okay? Now, what I'm showing you here are called Hox genes. Okay? Hox genes are the genes that actually are in charge of the body plan, so to speak. So here are the human Hox genes right over there, and there are our fly Hox genes right over there. Okay? Now, what's interesting, you might notice, that these Hox genes are actually coding for the formation of the vertebrae, right, your spine. Okay? But in the insect, it's actually coding for the exoskeleton. Okay? So what this movie would have to require is that Seth Brundle's spine slowly transformed into an exoskeleton. Okay? And that's not looking too good from the point of view of developmental biology. Okay. All right, now here's the good stuff. So this is the stuff I actually know about. Behavior and brain changes. And this is going to be my theory of the fly. All right, here are how flies behave in the lab when you put them under certain conditions. Oh wait, hold on. Sorry. Wait. I'm gonna. Okay. So I'm gonna show you flies that are aggressive. Okay, and they're engaging in fighting behavior. Okay, and there are 3 different types of these behaviors that we're going to witness. Okay, so the first one is the lunge. Okay. Yeah, that's like a body slam. Okay, here's the sneak attack. Yeah, all right. There we go. Oh, and this is called the tussle. Do the tussle. Okay. There we go. We're getting there.
These are fruit flies.
Ah, yes, these are fruit flies. And it's very interesting that you asked me that, because if you had been paying attention to the film, which we haven't seen yet, those seem like house flies, which are actually Musca domestica and not Drosophila melanogaster, which is what I'm talking about. Which means that, no, I'm just kidding. I chose Drosophila because of the amount of genetic research that's been done over the past 100 years. We know so much about that fly, so I thought it was a reasonable and not too far of a stretch. Okay, so those are the fly behaviors. Okay, but genes aren't everything. Okay, that means that context is actually important for the flies as well. And in fact, if you actually have 2 male flies, okay, they probably won't and then you put them in a little enclosure, they probably won't fight too much. Now, if you put 2 flies in an enclosure with cinnamon buns, then yeah, they're gonna fight over those cinnamon buns. And not only that, if you put a woman, or not a woman, a female fly, I'm getting confused by my own stuff. A female fly, and you present 2 male flies with that female, they will begin to fight each other to compete for this sort of courtship, okay, with their mate. Okay? So to increase the probability of fighting in the lab, what you need to do is either present the 2 males with the female or present them with food, which we will see in the film. So I think that this is actually very, behaviorally speaking, this is actually a very plausible scenario for brundlefly to become aggressive, to start yelling, to start smashing windows, to start doing these types of things. Okay, now, here's the neuroscience. Tachykinin is a neuropeptide that is in charge of a bunch of different functions of the body, including things like digestion, vomiting, and aggression, interestingly enough. In the male fly, what we can witness is that there are these neurons in the protocerebrum of the fly that release tachykinin that are only present in males and not present in females. And when these neurons are stimulated, when these 2 flies are in an enclosure, you can actually induce fighting behavior. So this is sort of like a kill switch or something like this. So you press the button, it basically stimulates these neurons, the tachykinin is released, and these flies become very aggressive. Okay, now in humans, we have a homologous system. That means that it's a sort of very similar, and it seems like they're actually the sort of human version of these tachykinin systems, is substance P. Okay? Substance P is associated with nociception, which is pain perception. Okay? So when this molecule is present, you'll actually, in certain synapses, you'll actually experience pain. But also, if they're present in your intestine, they'll actually stimulate smooth muscle movements. And in humans, there is some evidence to suggest that they are involved also in mood and aggression. So what I am suggesting, what my theory is that we have Seth Grundle's substance P system that is slowly transforming into a fly tachykinin system. And what we should expect is that there are some behavioral changes that go along with that. So he should be much more aggressive. He should be much more sensitive to those contextual effects, such as competition for food, competition for mates. Okay? And we might be able to observe that in the film together today. All right. So my last slide is just sort of some food for thought. We were saying before that the mind is often thought of as an information pattern. Okay? But what this film should bring to light, and what body horror as a genre should bring to light, is the importance of the visceral body, the importance of corporeality, okay? But also, this movie kind of brings us to what might be thought of as the post-human. So after man, there comes something. Whatever that something is could look very much like Seth Grundle. That is all I have to say.